Okay, let's get started. In this Rhino tutorial, we will be analyzing, extracting, and rebuilding simple primitives in order to correct common issues that we come across when we're doing our Boolean operations. First, I'd like to just introduce what these problems will be, and then I'll get into a couple of intro commands to make life easier in general. So the five common issues that I've found are, first of all, the open poly surface. Second, the non-planar face. Third, the non-manifold edge. Fourth, overlapping face or edge. And fifth, duplicate face or edge. So we'll work our way through all five of these examples. But first I would like to just talk about a couple of intro commands. First of all, planar versus, so planar here, versus object snap project. So I just wanted to show you how this works. It's very handy, and if you keep your faces planar, and you will make your life easier from the get-go. So for example, if I have the project on and I want to create a new polyline, it will automatically project to the construction plane. You can see that white line there, that's the extension line, and it shows to where it will be projected on the plane. And so this line, no matter kind of what I snap to, will always remain projected to the plane. So this line is planar. But let's say I wanted to have that plane not be projected to the construction plane. That line not be projected to the construction plane. So I'm going to delete it, and this is where the planar command comes into play. I'm going to do a polyline. I'm going to, before I do that, I'm going to click on planar. I've turned off my project. I'm going to create a polyline. And now I'm going to turn my project on. And this will allow me to keep my polyline, no matter where I click, planar to the initial point that I selected. So that is how you can make planar polylines that are parallel to the construction plane or projected to the construction plane. So that is kind of a relatively simple but important concept to understand when you move forward with your 3D modeling. I'm going to delete that. The next is the object visibility palette. I've noticed that when I see you modeling, many of the students modeling, they're not using their visibility palette. So I'm just going to go ahead and right click, pop open my visibility palette, and there's just a couple of commands here that I wanted to show you really quickly. First of all, I can hide I can do simple, I can hide and show, and then I can go ahead and invert selection and hide objects. And then I can do what is swapping the hidden and visible objects. So I have some objects hidden, so I'm just going to swap them out. And it's kind of like two opposite, or two different, I guess, models or so that I'm working with simultaneously. And depending on what's visible and what's hidden, that's what I'm kind of isolating and working on. So I can swap in between these primitive models and those book models, which we'll review later. I can also go ahead, and if I wanted to focus in on this first model, I can just quickly go ahead and isolate that and hide everything else. Now if I wanted to get those back, I can just come back here, grab those, hide them, and then flip again. And I'm right back where I started. So it's important to get all the clutter out of the way when you're working on these models and trying to figure out what's going on with them, especially when you have a much more complex model like I'm sure you all do. Okay, the last command I just wanted to show you really quick is up under your Edit drop-down menu. You can go to Select Objects, and you can select objects by type. So for example, I could select all of the points, I could select all of the text, I have all my text selected, and then that's a quick way you can then go ahead and isolate certain groups of objects by type. Okay, one more note before we get started is to never group your geometry. And we'll get into why not later, but you always want to join your geometry, you never want to group it. Okay, we'll talk more about that in a bit. Okay, so now let's go ahead and get started with this. First of all, we have an open poly surface here. And we know it's an open poly surface because we have our back face, show back face selected. And in order to control that, in the Mac at least, you can go to Rhino Preferences, go into Display Modes for shaded, not wireframe, but for shaded, and you can see my back face settings are set to a single color for all back faces, and my object color is set to magenta, and that is fine. I'm going to leave that just so. So it's important to note that every surface has a direction, and that the back of the surface, or the internal volume of a closed poly surface, is the back face. It is important to have a closed poly surface in order to Boolean it, and I'm sure many of you have gotten this dialog, so I'm going to copy this over here. Just going to copy it on, turn my project off, turn my planar off, copy this on the diagonal. Now let's try to Boolean these two. See what happens. Right, Boolean difference failed. So it's important that we have a closed surface, or a closed poly surface. So I'm going to delete that out. And besides your back face, you can also just quickly look at your properties, your object properties palette, and that will tell you that it's an open poly surface. So this is a really good frame of reference for when you're modeling. I like to keep an eye on what type of geometry I'm working with, whether it's a closed extrusion or a closed poly surface, text, open poly surface. It'll tell me if it's a curve or a polyline, so on, so forth. All right, so in order to get this to be a closed poly surface, because that's planar, I can simply use the cap command. So I'm going to go ahead and type in cap. And there we go. So I capped that, and it is now a closed poly surface. So that's a relatively easy way of dealing with an open poly surface, as long as the edges that are exposed, the naked edges, are planar. Okay, next. This has this issue of having a non-planar face. And I think many of you have been dealing with this issue. And for this model, what we're going to do is, first of all, extract some new curves and just re-extrude this shape rather than trying to fix what we currently have. So many times it's better to rebuild rather than try to fix your existing geometry. But hopefully you don't have to start from scratch, meaning that you can extract either curves or edges from the existing geometry to create a new volume. So what I'm going to use is the dupe face border command. And I'm going to click on this face, right click, and then you see I have a new curve. And then I'm going to use the extrude curve, the extrude curve command, in order to extrude that into a new, let's see what it is, new closed extrusion. Right. Alternately, with the non-planar face, with the primitive here that has the issue of the non-planar face, rather than extracting the rear closed polyline and extruding that, I could also go ahead and extract the here, let's go ahead and do it. Extract the face border here. So I can go ahead and go to dupe face border, click on that face there, and now I have a closed curve, but it's not planar, so I can't extrude it, but I can make it planar using the set point command. So I'm going to type in set point. Open that up. Here it gives us the set point dialog box. I'm going to be setting my points in the y-axis, not the z, and then I'll tell it to set points, and I'll go ahead and click to the grid here in the front and call that good. I'm going to delete the old curve, and now I can extrude this curve. So I can use my extrude curve command. There we go. The difference being that we used the set point command, which is an incredibly powerful tool, and you will be using it for many other applications besides simply, correcting non-planar faces. Okay, so next we have an issue that has been coming up as well. We have an object with a non-manifold edge. And oftentimes you only know that you have a non-manifold edge. Well, it will tell you when you try to Boolean it. So first we'll make a copy of this thing, try to Boolean the two. So it's telling me Boolean difference failure, non-manifold edge detected, and input may have caused Boolean to fail. Great. So I'm going to delete that out. And you can, let's see. So first we need to figure out where the non-manifold edge is. So I'm going to use a command called show edges. Oops. Not show the books, show the edges. So I'm going to show edges. And you can see right off the bat here, we have it, so we can have it select all of the edges of the object. We can have it show any naked edges, which there are none. Or we can have it show the non-manifold edges, which we have one there. So you can see that a non-manifold edge is an edge that's shared between two volumes, or it is a edge that has more than two planes intersecting it. So in this case it would have 1, 2, 3, 4 edges, or sorry, 4 surfaces or planes intersecting a single edge, or coming together at a single edge. So in this case, we will simply divide this into two objects, two closed polysurfaces, rather than trying to compose it of a single polysurface. So I'm going to go ahead and create a plane. Let's see if this will work. I'm going to do a surface plane rectangular plane corner to corner. And let's see if we can, we'll say done here. Let's go ahead and see if we can split this object. Great. So now we have it in two objects. So I'm going to delete that. I'm going to move this over here for just a second. I'm going to delete that. And now I'm going to go ahead and see if we can cap this. Oops. Great. So that's a closed poly surface. And then I will cap this as well. It's also a closed poly surface. Now I can move this right back over. And now when we analyze this geometry with the show edges command, we have all of the edges are manifold, meaning we do not have any non-manifold edges. Great. Okay, here, this is another common problem. We have an open poly surface, but instead of it missing a face, like our first example here, we have an issue with the overlapping of faces. So first of all, we need to we can detect the problem by using our show face command again, or show edges. We can have it show naked edges, so those are all of our naked edges. And it has no non-manifold edges. The colored back face is also a Q there, right? So in order to fix this problem, we will very simply rebuild this object in that we will first explode it. We will take the two surfaces that are overlapping and we will intersect them. And we've created a new curve, an open curve along the intersection, the line of intersection, and then we will use that curve to trim our planes. And then I will delete that curve. And then that will allow us to then join into a closed poly surface. Great. Now let's see what happens here. We have something strange is happening here. We click on this, what appears to be a single object, and our object type has multiple values. This is one of the more bizarre cases, and we see this quite often. So if I copied this over and tried to do a Boolean difference, we get a very bizarre effect, right? Essentially, one of these cubes has turned itself inside out, the other remains outside in, or outside remains normal, and then has a hollowing out of the face. Okay, so Let's go ahead and undo that. This is a classic case of having grouped geometry stacked on top of itself. So I'm going to go ahead and ungroup, and then I can either find the surface like so, or if it's more complex, I can explode this, and then I can say use the cell dupe command, and I can find out that there is a duplicate face on the top there. I can delete that duplicate geometry and then go ahead and join the rest together into a single closed poly surface. Now when I go ahead and copy that over and Boolean difference it, we get a much more expected result here. Okay, I think that's it. So some of the commands that we just went over the difference between planar and object snap project. We went over the object visibility palette. We went through how to select objects by type. We looked at the object properties palette in order to determine whether a poly surface is open or closed. We used the show edge command. We looked at how to set backface color. We used the cell dupe command. We also looked at how to determine the direction of a surface. In extracting geometry, we looked at the dupe face border and the intersect commands. And then for rebuilding geometry, we went ahead and took a look at the extrude curve and the planar surface command. And I believe that's it.